So continuing along with the review, starting with problem number 11 here, we're asked to find all the roots and write it in factored form. That's really easy, especially if you use Desmos. Of course, you can use graphing calculator as well, but it's here programmed on Desmos. The nice thing is that you can just click on a few things and find points of intersection. So those points are at x equal -2, x equal 1/2, and x equal 2. So to write that in factored form, what I would do, and let me get back to my window here. What I would do is, first of all, I'd multiply both sides of this by 2 and get 2x equals 1. And then with all of these, I would move this to the left-hand side so that I get x plus 2 equals 0. Here, 2x minus 1 equals 0. And here, x minus 2 equals 0. Now we've got it nice and neatly parsed out like this. We can just multiply these together as x plus 2 times x minus 2 times 2x minus 1. The order doesn't really matter, just as long as they're multiplied out. Beautiful. And that's it. Let's look at this next one. Reverse engineering, kind of the same way. X equal -3 is a root. X equals 0 is a root. And x equal 2 is a root. The corresponding binomial will be x plus 3. Here you can just write x. You can write x minus 0 if you really want to. Then here would be x minus 2. Behavior here is a bounce. That gives it a multiplicity of 2 or 4 or 6 or 8, but we'll go with the smallest one. The next one is straight through. That means it has a multiplicity of 1. And the final one is a wiggle. I know these are really technical terms. That means it has a multiplicity which is odd and greater than 1. If we put all these things together, then we can come up with the equation p of x equals x plus 3 squared times x minus 2 cubed. Now that's a nice even degree polynomial, which is what we see here, but unfortunately these face down. So to correct for that, or to account for that, we'll put a negative here and we're done. Nice. Let's keep going, again with polynomials. Problem number 13 has the wrong end behavior, so that's a problem. Also, this should be shifted to the left 4 and up 2 from the center, which is 0, 0. It's been shifted to the right by 4 and down 2. So that point, in case it's not showing up too good, is 4, -2. So it was shifted the wrong way. So there's a couple things wrong with that one. Problem 16, we'll start out by writing y in place of f of x. And then we interchange x and y. So it's going to be x equals 7y over 3y minus 5. We need to solve for y, so I'll multiply both sides by the denominator. On the right-hand side, it's going to cancel. On the left, I get x times 3y minus 5 equals 7y. If I distribute right here, I get 3xy minus 5y equals 7y. No, that should be a 5x here. My bad. 5x. Let's get the y's on one side and the x's on the other side. So let's see. I'm going to put together the y's over here. So that's going to be 3xy minus 7y equals 5x. The last little trick here is you're going to factor out the y times 3x minus 7 equals 5x. Now you can divide by 3x minus 7. And then remember, when you're all done, write that as f inverse is 5x over 3x minus 7. If you were to graph this function and this function on the same graph, they should be mirror images of each other around the line y equals x. F of x is going to be shifted to the left by 23 and up by 17. So if I want it shifted to the left by 23, that's going to mean a plus 23 in the exponent, and then up by 17 would be a plus 17 there. If I wanted to shift it around the y-axis, that is reflected around that y-axis, is going to be e to the negative x. A couple nice friendly ones. Log of this base, so log base 125 of 25 equals 2/3. You can always double check yourself. It should be this to this power equals this, or likewise this to this power equals this. And in our case, that's going to be 4 to the 3/2 power equals 8. And as far as this one is concerned, you can check that on your calculator. 4 to the 3/2, plug that in, make sure you get 8. This is just showing that the logarithm and the exponential functions are inverses. So there you get a 47. Here I get a 7. And here the 3's cancel each other out, and I'm left with a 29. Nice. Let's keep going. So we want to use the properties of logarithms here. Hopefully you remember the product rule, the quotient rule, and the power rule. The first thing that comes to mind here is that you've got to do a quotient. So that's going to be the log of y to the 6 minus the log of that square root term. I'm not going to write that. I am going to clean it up over here. That's going to be log of 6 times the log of y minus, this is really, I'll squeeze it in, 7x squared. It's really 7x squared to the 1/2 power. So log of 7x squared all to the 1/2. And now that 1/2 can come out in front. So it's going to be 1/2, excuse me, gotta have the 6 stuff there first. 6 log of y minus 1/2 log of 7x squared. The tricky part here is that that 1/2 has to distribute itself to both of those terms here. I'm running out of room, so I'm going to do this all in one shot. It's going to be 1/2 times log of the product is the sum of the logs. So it's going to be log of 7 plus log of x squared. But that 2 that is here can come out in front. So that would be your final answer. Or you could distribute the negative 1/2 to both terms. If you're going to distribute, that's fine. You can write it without parentheses. If you want to write it without parentheses, then you got to distribute that negative 1/2. Over here, this is log of the square root of x cubed times the square root of y. So that's going to be x cubed times y to the 5th. 5th is to the 1/2, and 1/2 there again. Let's clean all this up. That way it'll make it a little bit easier. I'll start by multiplying in the 1/2 here. So it's going to be log of x cubed y to the 5/2 raised to the 1/2 again. Now that 1/2 is going to multiply both of these exponents. So it's going to be log of x to the 3/2. 1/2 times 5/2 gives me 5/4. Again, I'm running out of room, so I'm going to do this in one step. You're going to use the product rule first. It's going to be log of this plus a log of that. And then the exponents are going to come out in front. So your final answer should look like this. So it's going to be 3/2 log of x plus 5/4 log of y. Beautiful. This is a good one. There's a couple ways to solve logarithmic equations. You're stuck with only one of them here. I'm first going to write this as log base 14 of x minus 3 times x plus 2 equals 1. And then let's distribute and clean things up in the parentheses. That's going to be x squared plus 2 minus 3 is going to be minus 1 minus 6 equals 1. Now, because I don't have log on both sides, I've got to do this the long way, and that is I'm going to rewrite it using exponents. So it's going to be 14 to the first power equals x squared minus x minus 6. If I move that to the other side, I get x squared minus x minus 20, and that factors as x minus 5 times x plus 4, and that's going to equal 0. That is a 0. That's true when x equals 5 or x equals negative 4. Unfortunately, negative 4 is not going to work as a solution because if I plug in negative 4, I end up taking the log of a negative number. So I have to throw that one out. 5 actually does work. And so 5 is your only solution. This one is extraneous. These are different lines. So let me be clear that you're looking at this line here and this line here. So those are different lines. The fact that they are different lines means that these are independent. That's an independent system of equations. Eventually, these have to cross. They're not parallel. So if they have to cross, then they're consistent. To solve a problem like this, what you're going to do is you're going to let y equals 2 to the negative x and y equals x minus 5. And then, let's see, I think I've got this one on Desmos. So that's, where is it? Come on, there we go. That's right here. Let's shut this one off, turn these two on, and basically just want to look for their intersection. I don't think it's at negative 5. Or excuse me, at positive 5. I think it's a little bit above that. If you zoom in enough, you can actually see the intersection as opposed to the x-intercept. Bam, there we go. So what we're looking for is the x value. So it'd be 5.013. It's going to be 031. And that's your answer. Yay. The next one, again, you can graph. There's a couple things you should be aware of. That's this one. Let me hit the home button here. That'll zoom me out a little bit. So a few things I'd be looking for. I'd be looking for the x-intercepts. There's 2 of them. Actually, there's 1 of them. That's where the numerator equals 0. So basically, where does 4x plus 12 equal 0? Oh, at negative 3. So negative 3 is your x-intercept. Y-intercept, that's where the graph crosses the y-axis. If you set x equal to 0, in fact, I can do it this way. Let's do f of x. And then underneath here, I'll do f of 0. Should give me negative 12, or excuse me, negative 4. Because you get 12 in the numerator, and negative 3 times 1, 12 divided by negative 3 is negative 4. And that's exactly what this is. So, beautiful. Let's take a look here. What else they're asking for? So we got y equals negative 4. Horizontal asymptote. Because the numerator is less than the denominator in degree, your horizontal asymptote is 0. Your vertical asymptotes are going to be where the denominator is equal to 0. So 3 and negative 1. The domain is everything except those points. So it'd be negative infinity to negative 1, union negative 1 to 3, union 3 to infinity. Let's do a couple more. Find all the real complex roots. So the real roots of this are going to be, well, let's take a look here. Let's look at the graph. Turn that one on. Well, there's only one real root, but you should notice something about that real root. And that is that real root has a multiplicity of 2. Why do we know that? Because it's got a bounce. So let's keep that in mind as we try and find the rest of the roots for this polynomial. So let me go back to this right here. If 1 is a root, then this should give me a 0. And we're going to start out with a 0 here. 1, 1, be -1, -1. So remember, multiply and then add 9, multiply, add, 1 times -9 is -9, and then add. So beautiful. We end up with 1, -1, 9, -9. We can do that again because we know that 1 is a root twice. So 1, -1, 9, -9. That gives me add going down. So 1, multiply to go up. 1, 0, 0, 9, 9, 0. So that ends up being x squared plus 9. I know that 1 is a root twice. So the factorization that I get is x minus 1 squared times x squared plus 9. If I want to finish solving this and finding all the roots, then I can do this, move the 9 to either side, and get x is plus or minus square root of -9. Hopefully you give me the plus or minus and the 3i. Overall, the factorization would look like this: x minus 1 squared, x minus 3i, and x plus 3i. Beautiful. Okay, last one here. For this part, you've got an exponential equation. You have to take the log on both sides. You can only take the log of either base 4 or base 5. That'll help you out pretty nicely if you do that. I can take the log of base 4 on both sides because it looks like it's going to simplify a little bit nicer. Log base 4 of 5 to the x minus 3. These two things are going to cancel very nicely. It gives me 7x plus 2 equals x minus 3 times log of 4. We need to solve for x, so I'm going to distribute this to both terms. 7x plus 2 equals x log base 4 of 5 minus 3 log base 4 of 5. Let's move the x's to the left-hand side, so that's 7x minus x log base 4 of 5 equals -2 minus 3 log base 4 of 5. Factor out the x. Let me change colors here so maybe it's a little bit clearer. X times 7 minus log base 4 of 5 equals -2 minus 3 log base 4 of 5. And then, wait a minute. Okay, yeah, looking good. Finally, x equals -2 minus 3 log base 4 of 5 divided by 7 minus log base 4 of 5. Oops, ran out of room there a little bit. Beautiful.